Hello everyone. Today I will show you how to do buckling analysis of steel plates by using Abaqus software. So we'll be doing analysis of plates without any hole as well as the plates with central hole like this. The size of the plate is given as 400 mm by 400 mm. The thickness is 5 mm. So we need to calculate the buckling load by considering first 5 modes. The plate is fully clamped at the bottom. So bottom edge is fixed, and for the top edge only vertical motion is allowed, and for the side edges we will be applying roller support. The E value is given as 210 GP, was poison ratio 0.3. Now for the second part we will be considering different radius of holes like 30 mm, 50 mm, 70 mm, and we will check what is the variation of buckling load with the change in hole size. So I am just modeling the plate here. So cell planar and increase the grid size. So using this tool, we are creating a rectangle like this. After that, we need to give the dimension using the add dimension tool. So this is 400 at the bottom and right 400. Similarly for the vertical is 400. Done. Now go to the property module. Create material and give the name steel. Mechanical, elasticity, elastic, Poisson ratio, and Young's modulus. Young's modulus 210 into 10⁻³ MPa. Poisson ratio 0.3. Now create a section. Cell, homogeneous, thickness is 5 mm. Okay. Now assign the section. After that, go to the assembly, create instance. Okay. After that, step module, create step. Here the procedure type, linear perturbation, then buckle, continue. So here we need to give number of eigenvalues required 5. Then okay. Now from the load module, we need to apply the boundary condition and loading. So using create boundary condition. So at first I'm creating fixed. Go to the initial. Then using this option, continue. Bottom support. Use the last option. All the degrees of freedoms are restrained. Fix support. Now again go to the create boundary. So for the top, we will be using displacement or rotation option here. For the top only, vertical translation will be allowed, all other are restrained. Now for the vertical sides, we will be only applying roller support, that is U3 is restrained, all other are free. Okay. So after that, I need to apply the loading also. So for buckling load, for the calculation of buckling load, we need to apply a unit value of load, and the software will automatically calculate what will be the buckling load. So at first I'll show you the easy procedure. So go to the mesh module. Okay, so the easy procedure. So I am just applying the load as a cell edge load. So as a pressure, we are applying cell edge load. So in step 1, cell edge load. So here unit value 1. So this is basically is applied as a pressure, unit pressure. So whatever the buckling load will be coming, that is in terms of pressure. So finally we need to multiply with this length to get the buckling load. Now go to the mesh module, seed part. Okay, we need to go to the part here, seed part, done. Then mesh part. After that job, create job. Okay, then submit. Completed. So go to the results. So you can plot contours from here. So it is eigenvalue is coming 1001.8. So it is basically in pressure. So here this length of this is 400 mm. So if we multiply with this pressure value into 400, so basically we are getting around 404.8 kilonewton buckling load. Okay, so this is pressure. So to get the buckling load, we need to multiply with 400. So by multiplying with 400, we will get in Newton. So divide by 1000, we will get in kilonewton. So 400, 4. So basically 400 into 1001.8 divided by 1000. So it will be 400 into 1001.8 divided by 1000. So 400 0.72. Okay, so it is coming like 400.72. So this is for the first mode. Now you can check the second mode, this one, third mode, fourth mode, fifth mode. Okay. Now I'm showing another procedure how to get the buckling load directly instead of pressure. So for that, we will not apply as a pressure. So from the mesh module, we will be basically creating node sets. So from this assembly side, so here there is a sets option here. So go to the sets, then load node, select any one node like this. Then again go to the sets and follower nodes. Then node. So except the load node, we will select all the nodes as a follow node. After that, go to the load module. Now create load. So now we'll apply concentrate force. So here from the sets, select the load node. We apply the load. So in the direction 2, it will be -1. Now from the interaction module, we'll create a equation tie. Coefficient is 1, -1. So follower nodes, dot node, TOF 2. So basically all the nodes here will be moving at the same time when the load will be applied. Okay, so basically the load will be automatically distributed over the uh, to all the nodes. Now go to the job, submit. Completed. So go to the results. Okay, so now you can check that we are directly getting the buckling load. So this is basically the force we are getting directly, not the pressure. So it is coming 401 point, sorry, 4016 into 10 to the power 5. So if we multiply with 100 here with 4.01, then it will be in kilonewton. Okay, so for 401.6 into 10 to the power 3, it is basically. So the buckling load here coming is 401.618. So this is the first mode. So this is the second mode. This is third mode, fourth mode, fifth mode. Okay. Now I will show you how to create a hole and again do the analysis. So for that we are going to the part module. Okay, so before doing that you can save the file as plate solid. After that save the file again by another name, plate with holes. Now I am editing this file here. So go to the part, then features, then section sketch. So if you are doing directly without modeling the solid plate like that, then you can what you can do when you are drawing the rectangle. After drawing the rectangle, you can directly draw the circle. So after drawing the circle here, we need to give the dimension. So click here, then click here. After that again click here. So it is 30. So enter. So at first we are doing with 30 mm, 30 mm radius. Now we need to check it. It is at center or not. So this should be 200. Again checking another dimension from this edge. This should be also 200. Done. Okay, so now we need to from the features right click, then regenerate. Then the hole will be created. After that, to mesh it properly, so I will show you what will happen if we mesh it like this. We go to the mesh module. So if you mesh it, it will be arbitrary mesh like this. But if you want to generate a good mesh with, I mean, uniform from all the sides, then you need to uh, divide it. You need to do some partitions by using this option, partition face or sketch. So we need to select a vertical edge. After that, we will be creating some lines like this. Then also from the vertical side. Then again from the corners. Like this. Now using this option auto trim, we will trim is okay. Now cancel the procedure. Done. Done. Okay, so here I have partitioned the plate like this. Now go to the mesh module. So here we need to again seed the edges properly. So here I'm selecting all these lines here. Say we need a finer mesh at the center because there will be some stress concentration. So we can use the bias option like this. After that, the direction of arrow will be the having the final mesh. So we need to flip some directions. So select. So whatever the direction should be flipped, you select. So at first select one, after that press shift and select the all required, then done. So now all the arrows are having direction towards the center, then done. Okay, so you can also choose a finer mesh size in the this periphery portion also if you want. Now we need to also do some assign some mesh control. So selecting all the partitions, now here sweep. So we will be using the sweep method, then mesh part. Okay, so now the mesh is uniform. After that again we need to assign the loading, and for that so we are using the load node and follow node, that option, that thing, to apply the uh, to get the buckling load directly. So here we are reselecting the load node, because after the remeshing it will go. Now reselecting the follow nodes like this. Okay, so you can check the load is automatically applied here. Now go to the job, create, let with holes, let with hole. Okay, now submit it. Results. Now you can check that the buckling load is 3.49 into 10 to the power 5 Newton, that is 349 uh, 349 kilonewton. So previously it was around 400. So now it is around 350. Okay. These are the other modes.